Welcome everyone to another webcast. Today's webcast for all things DevOps and SRE. We'll be covering the topic of cloud cost optimization.
That's a great topic.
Yeah,
it
is a very good topic. I'm Vish, and this is my co-host Dodi.
Hello.
And today we have a special guest with us, Dr. Muj Sultan. Dr. Muj, do you want to maybe introduce yourself?
Thank you very much. My name is Mujahid Sultan. You can call me Muj, and you have picked up a really good topic today. Cloud cost is a pain in the butt for most of the organizations who wants to be in the cloud or who even are born in the cloud. So it's a very interesting topic, and I'll be glad to talk more about it. And probably I would have some demo for you guys. So thank you for having me.
Great.
All right. So let's get started.
Yeah. So do you want to maybe give us a brief introduction to your company, MLSoft, and how it's having an impact on this landscape?
Okay. MLSoft is the new startup under umbrella of companies which iVedha has. And though we specialize in building machine learning models for different businesses, and hosting them means the DevOps part of machine learning, which is called MLOps. But in last year or so, we've been engaged in different offerings, particularly in cloud space, and one of them is cloud cost optimization on multi-cloud. So that is, I think, you guys want to talk about today, and I will be able to showcase a product which we built for ITRA, and it is, though we are not done with the product, but the MVP is there, which uses machine learning. That's why our expertise at machine learning. So that tool uses a lot of machine learning and a lot of very good visualizations for multi-cloud cost optimization.
Okay, Muj, thank you. So I guess today's topic, what Vish is saying, it's talking about cloud cost optimization. Let's get started.
Question. I see some question on the screen.
Let's talk about that. Let's talk about cloud cost optimization. How do you think it relates to DevOps and all the other things related to it, especially when you're dealing with multi-cloud providers?
Good question. There are a lot of different facets to it, a lot of different ways of looking at it. But if we look at the cloud native applications, DevOps actually practice started with cloud native, though it can be applied to the monolith or the other side of the development. But it's mostly for microservices based cloud native applications development. When you develop applications using microservices and DevOps practices, you are basically 90% of the time you are developing applications for the cloud, and they will be hosted on the cloud. And when they're hosted on the cloud, general estimation is about 30% of the hosted cloud environment is wasted completely. 30% or above, and that is some of the major organizations. They did that analysis in 2020, that 30% of the cloud spent basically is wasted. So these two areas are now very much tied together, that if you are doing DevOps, you are doing DevOps for cloud native applications, and those will end up in the cloud somewhere, whether it's a private or public cloud. And today we are talking about three major clouds which we have tackled today. From single pane of glass, you can control and see. First of all, you can see your costs. There are a lot of wastage in the organizations, and just to give you an idea how much wastage it is. To my astonishment, I actually participated in AWS reInvent in 2019, I believe, and they have a guest speaker, Expedia CEO. He went on stage And you have already on current challenges. Yeah, it's one of the challenge that he went on stage and he said, we are very happy to be partnered with AWS, and we have saved tremendous amount of money on AWS. And here is our cloud spend, $980 million for 1 year. And I looked at him as, if that is saving one simple, vacation booking system. They're spending $980 million on cloud hosting and AWS. Are they utilizing the full power of what they're getting? Probably not. And at that time we were, in infancy of building this app. But now I can say, when I look at some of our clients, they are wasting a whole lot, resources on the cloud.
Yeah, and how do you actually see it from the cloud cost optimization when we talk about the challenges, Mooj?
Right.
We started looking at, hey, I think, would you think that that's part of the automation challenges that brings along on when you started doing that in DevOps? Is that more of the responsibility of the governance team to actually do it, or it's more like a shared responsibility again, having knowledge of the different environments, different public cloud providers versus private, the business model change, right? How are you seeing that?
Yeah, it's a good question, and it has multiple ways of looking, multiple angles we can answer that. So it's definitely a shared responsibility. It is not, a single department's responsibility. So let's have a look at it, what the challenges actually are, right? Where is that cloud compute waste going? The very first one is visibility. People don't know what has been provisioned. A lot of dangling, or a lot of unused instances are always there. Somebody spun up something, whether it's a DevOps team or some other teams. They spun up something and it's never taken care of, and it's dangling. It's not part of your CDCI pipeline, for example, and nobody actually cares about it. Other is, it is part of your DevOps lifecycle, is part of your deployment through that CDCI pipeline, but it's underutilized. So that underutilization, is not job of DevOps alone, to measure that. Now somebody has to actually measure it, and that goes to the basically operations, not only the operations but FinOps teams, who should be looking at where are we spending that. And then comes the governance. So it's a multifaceted. All responsibility is shared among all the teams. But when that instance was being provisioned, even by DevOps teams, it's not properly tagged, right? So tagging is afterthought sometimes. So there is a lot of organizations who have provisioned hundreds and thousands of instances without knowing what they're doing, which account we should bill to, within the organization, how they're classified. So what we do is in our app, you can go and discover automatically what is there, and we can display it for your decision making, and you can change it there so that you know who to bill to internally. When you know that particular instance belongs to a certain department, then you can put governance around it. Then you can properly do the FinOps around it, right? So that's one of the challenge, that they're not, tagged properly, right? Third challenge is, when you look at it, how much headroom do we have, right? Can I bring more applications onto that instance? Let's say I'm running M3 or extra large M4, huge capacity I have there. How much capacity or how much headroom I have? So if you go onto the cloud interface, they make it complex on purpose. The same way they make it complex, the billing, they make it complex on purpose, so that nobody understands, nobody does anything. So they make it very, very, very complex. 10 different clicks you have to get to, information. But what we do is, we looked at the industry pain points, and we highlighted them at the very beginning that, you should be able to know how much headroom you have in a particular instance so that you can bring it more load onto it, right? So that is what we have done upfront. We show you mostly memory, CPU, and disk. Disk you can have attached versus the separate storage, but CPU, memory, and also to some extent network. What is costing you more, whereas you have more room so that you can utilize it properly. Now this is the third pain point industry has. Fourth pain point is the forecast. Based on my client or my history of that workload, how my instances are going to scale up in future. Even if you tell me 1 week so that I can move them around, and I'll come back to what is moving around means, then we can save a lot, right? So forecasting in the cloud, they tell you next day only, right? They only keep 12 to 15 hours of data, and they tell you next day, and they're not going to tell you the actual story if you are underutilized, because they don't want you to, go away from it. So we capture the data. Our app captures the data for the life cycle of the instance. Since it was created, it's not only 15 hours; it can be 15 months. And based on your utilization, we use machine learning, and everybody, I think, audience knows one particular type of machine learning is using deep neural network called LSTM. LSTM is a recurrent neural network which is used for time series forecasting. So we use that multi-layer LSTM to project your spend and or your utilization into not only days or hours but weeks. And it does pretty good job. And even if you have enough historical data, we can move it to a month, and it takes care of all those forecasting elements. For example, how much cycles you have in your business, what are the holidays coming up, what are the other instances come up where your load spikes up. So it takes care of all those time series, things to project your load into future. And when you know that this particular instance is, has a lot of room in the future, you can manually move it to a smaller instance, because all these clouds now allow you, if you do not change the type of that instance, then you can move it without any cost to save money. For example, an extra large with I think extra large is 16 processors. If your application is low on processor, it is running about at 10% of capacity, you can move it back to not extra large but to the large, and saving. You have now one large spared for you where you can run other applications. You can do that for free using AWS. AWS started that, but all the cloud providers, Azure and GCP, they offer that now. So that's one very big area where organizations can, smaller as well as big organizations, can save a lot of money when they see that kind of forecast. And I'd love to share that screens which we have developed and on a real client.
Yeah, so let's talk about that, Mooj, and thanks for that well described and explained answer. So maybe what you could do is, I know from MLSoft's standpoint, you are going to show something live in here in the audience today. Can you actually want to share your screen and demonstrate something?
Yeah. So I think my screen is coming up. So I think my screen, you have a control to share my screen, I think, or no?
Yep. So as soon as we get the share,
right,
share that.
I have given you that control. You can bring it up. Okay. Yeah. Thank you. So this is our client is internal client ITRA. We have built this for ITRA, and ITRA, as you know, is a software for MSPs with a multiple clients on it. So how it works is, you see on the top it says MSP iVedha. So we actually expose an API. That API through tokenization with multi-factor authentication, you provide your cloud credentials. For example, you are running GCP, Azure, and AWS, for example. The moment you provide that credentials, let me move my mouse. Can you see my mouse?
Yes, we can.
Yeah. So the moment you provide your credentials, now you are logged in into. We go into the cloud, multiple cloud, and we activate, your cloud monitoring. It's not by default. It's a very little charge. For example, AWS calls it Cloud Watch. Azure calls it Cloud Monitor, and GCP also calls it Cloud Monitor. There's a little charge, to enable that. And to enable that, you either can manually go or you can run a script. So we run a script. AWS is the most because there everything is closed on by default. Everything is closed down until you open it up. So we have to run some Perl script, on your AWS cloud, which is available on S3 bucket. We have to just from there pull it and run it so that the cloud monitoring starts. When that cloud monitoring starts, this is the screen you see. Right? So all your clouds are going to show up here. Now, if you can see on the right side, you have Azure under this account, GCP, and a cloud stack. So let me, the moment you go on, let me go on GCP, for example. All the instances you're running, they're gonna show up in the next drop down. You can see there are 3 instances right now running. This is a small account. I just picked it up just before our demo. I didn't want to go into the actual client's data because of the proprietary things. So here it's going to show the moment you select a cloud. For example, now let's go back to AWS. So it's going to show you the instance you are running. Now, on that instance, if you just expand the very first tab here, it's going to show you the headroom. Let me pick other instance because this instance was not showing me memory. And the reason is the Perl script probably didn't run on that. We need to run that. So here we go. So this screen alone tells you a lot of things. For example, look, this instance was never tagged. So if you want to do governance or billing, you don't know who it belongs to within that department, right? Then it tells you what this instance is about. This is T2 large. This is much as memory it has. This is attached disk. And the network, it is running low to moderate. A lot of the times, people don't realize that there is egress charges, right? And if you're running on an instance, for example, this instance has a low to moderate network coverage. And I think if you go on their website, you can read it's 9 gigabyte is included. After 9 gigabyte, they charge you per egress charges. Sometimes your egress charges can grow so large, that you need to move that instance to a bigger network enabled instance to save money. And this is what we're going to do here, right? So you can see this red is basically as little not good legible here, is a little grayed out. We need to make it a little more whiter. But you have a headroom of about 98% on memory. You have a headroom on this instance of about 65%, right? So these two matrices alone, I can very easily move it to T2 micro or T2 nano, right? To save more than 1/3 on the price of it. So to do that, basically, I won't expand this yet, but you can migrate that, to another instance. You can stop it. You can manually migrate. Right now, we are keeping it manual, but you can do automatically too. But before I migrate, I want to show you, your forecast based on LSTM. And then I'll come back. There are a few things we are displaying here. If you want to know, for example, how much are my egress charges, you can select some custom matrices which are not available in the cloud. Let me select the egress charges now. Egress, where is egress? Egress, for example. Oh, this is a new instance, started last night. Nothing is happening there, so there's no egress charges. Let me pull GCP instance and see if there are egress charges. this application. Oh, here they are, right? So you see there was a spike, then it came down, and and let's see, based on this historical, how this instance is gonna scale in the future for egress charges alone. Now you go to LSTM. I see little lag is because maybe my screen is being shared. Otherwise, this is pretty fast app. So now I go and forecast. We going to forecast that here is the forecast. Come on, show it. Much loading. I think these are, you can slide the forecast. This is for 24 hours. It is too small a scale. Let me make it a little bigger, and then it will show up in the future. So now I'm almost about 4 or 5 days. I'm going in the future and generating the forecast. So based on the forecast, what you can do is then decide whether to move that application up. And I picked too much, it went too much in advance. But you can see this application, the forecast is not that, this is the maximum, it's going to go up. And based on that, you can, go up and, either stop or start or migrate that instance, right? Or migrate to, a smaller or even bigger. If your stats are going too much, if you figured out you're going to run out of capacity, you can move it to a bigger instance without any charge, right? So that is what this tool offers you from one pane of glass. You can monitor your entire cloud, and you can move. You can also do automatic movement onto reserve instance as well as spot instance. That is the feature which we are working on these days, that whenever reserve instance in that region or spot instance is available, we can move there and back and forth so that you can save money.
All right. Well, thanks, Mooj. So what's next for MLSoft?
Well, MLSoft is working with multiple clients and doing things in machine learning, artificial intelligence domain. One of our clients is in healthcare, where we built an intelligent agent for them using Kafka streaming, for example. They have multiple applications which are connecting to service bus and for concurrency control and for load balancing. We wrote enterprise service bus for them using Kafka, which can take very huge loads, as well as we did their transformation of their data using machine learning and artificial intelligence. So not the regular ETL task, but some intelligent ETL tasks. So then we deployed that into a scalable infrastructure, and we then monitor their infrastructure so that if we can save some money in moving the workload around into smaller instances, we also do that. So these are the areas MLSoft is working these days.
Oh, thank you.
So you're staying busy then.
Very busy.
That's
Okay.
always good to hear.
I think there's going to be much more. I know we can do a deep dive more on the cost optimization area
Right.
on our next series. I know we're building that up, so I'm sure you're going to be showing over the next sessions as well. You're going to have more time to actually show and demonstrate some of these types of projects.
Definitely. MLSoft is also working on a product on security, cloud security, how we can use machine learning to improve the IDS, IPS, or SIEM, how we can improve security in a cloud native applications. That's another area we're working on, and I'd love to share that with you.
Wow, it sounds exciting. Okay, well, thanks a lot, Mooj. Thanks for taking the time to be in this webcast,
Thank
and
you.
we'll see you soon.
Yeah, thank you so much, guys. Thank you for having me.
Thanks, Vish.
Thank you, Billy.
Thanks.
Take care.
Take care. Bye.